Okay, for today, let's discuss question 7 and 8 that I assigned to you last week. For question 7, it states that compound X is equal to, the formula is C4H10, produce two structural isomer, which are isomer D and another one is isomer E. And isomer D is known to possess high boiling point, high BP compared to isomer E. And isomer D is reacted with Br2 plus Br2 in the presence of UV light to produce 2-bromo-butane. Okay, let's draw the structural formula for 2-bromo-butane. 1, 2, 3, 4. 1, 2. And then CH3. Here is CH. Here is CH2 and CH3. And the question asks you to illustrate and indicate the IUPAC name of the isomer the isomer D and E respectively. So, and suggest B, the question B asks you to suggest the complete chemical equation for the reaction of 2-chlorobutane with zinc in the hydrogen chloride. And normally for this part, this is referring when you see this condition, of course it is referring to radical halogenation substitution. Means that one hydrogen at the alkane group is substitute with one halogen group, one halogen atom. For example, here I think you need to do the reversible reaction. Okay, here is D plus Br2 in the presence of UV light. And you get this one, this product. And how to know the structure for isomer D. Basically here is a radical halogenation substitution. Always remember, when reaction involved with radical halogenation substitution or other reaction, always remember in your mind the starting material here should be alkene, and here should be other functional group lah. Okay, which is here is referring to alkyl halide. So of course we know that one hydrogen here should be at the beginning of the reaction is substituted with bromine. So the starting material should be like this: CH3, CH2, CH2 and CH3. And the starting material is butane. Means that one hydrogen here is substitute with bromine at the end of reaction. So this is your starting material. This is your answer. And the question asks you to, this one is illustrate and indicate the IUPAC name of isomer D. And the IUPAC name is butane. And for isomer E, so of course isomer D is known to possess higher boiling point. Why it possess higher boiling point? Because it is a straight chain. High BP due to straight chain alkane. So more high surface area so more energy need to use to break here is break intermolecular forces, hence BP will increase. Okay, basically this is the explanation, not the answer. Actually, I want to explain to you why the question state that butane is possess high BP compared to isomer E. So what is isomer E? So in this question, produce two structural isomer D and E. So to draw the isomer E, basically this is the same molecular formula but different arrangement of atom in the structure. So it is referring to constitutional isomer. Maksudnya kat sini, actually soalan D dengan E ni adalah basically dia mempunyai bilangan carbon and hydrogen yang sama, tapi dari segi susunan of the carbon and hydrogen tu berbeza. And it state that isomer D mempunyai bilangan mempunyai boiling point yang lebih tinggi berbanding dengan isomer E, because isomer D is a straight chain alkane. Maybe for isomer E, it is a branch alkane. Okay, how to draw the branch alkane for isomer E? So you need to reduce, remember I explained to you in previous class, for this constitutional isomer, you need to reduce the number of carbon in the straight chain. After that, you need to make it another carbon to become a branch. So like this for isomer E. So C4, right? So C4 you need to reduce to C3. 1, 2, 3. So where is another one carbon? So you need to make it as a branch. So C. And make sure you need to fill in all the hydrogen here. So CH3. And then here is a CH3. Here is CH3. Here is CH. So 3, 6, 9, 10. So here is isomer E. Isomer E is we consider as branch alkane. Okay, why branch alkane is possess lower boiling point compared to straight chain alkane? Why? Because the structure of isomer E just like sphere. Okay, sphere. When you stack this sphere, okay, you have sphere here, sphere, bulatan. When you stack, kan, you see here the surface area that touch each other is quite less compared if you stack the straight chain alkane. If you stack like this, so stack tu susun lah. So means that the surface area that connect between these both here is much more. So it has a more intermolecular forces, so it need more energy to break the bond between this molecule compared to the branch alkane, which is in the form of sphere. So uh, the connecting between the sphere and the sphere is much more less. So less energy need to be used to break the bond between these two spheres. So less energy, and so that's why the boiling point is much more smaller, much more lower compared to this one. Okay.